Okay, so today I will show you how to make this cool looking 3D menu using the Arduino UNO and the OLED display. And this display is a transparent OLED display, which I think looks especially nice, but you can also use non-transparent OLED display, for example like this one. This is actually my favorite one because it's quite big, around 1.5 inches. You can also get those OLED displays in smaller size. I have those 4 in all the different colors, being the white, yellow, blue and this one. This is quite special because it has 2 colors, but it's not like you can switch between those. It shows the first 16 lines in yellow color and then the rest of the display is in blue color. And in my case, I've rotated the display by 180 degrees, which means that I can use the yellow area to show the label, and then those icons are displayed in blue color. You can also get those OLED displays in a bigger size. Those are around 2.5 inches, and you can get those in yellow, white and blue color. But what's kind of special is you can also get it in a green color, and that's quite unusual color because I don't think that you can get those smaller displays in a green color. Now, the reason you can use any of those displays without even changing the Arduino code is because even when they are different color and different sizes, they all have the same resolution, being the 128 by 64 pixels, and they all use the very same driver chip, being the SSD1306. But we will get to it later. For now, let's start with our 3D menu. Actually, before we talk about the menu, let's talk about the sponsor of today's video, which is PCBWay. And the reason the PCBWay is sponsoring this video is because I believe they are a perfect fit, because sooner or later you might need PCBs or PCB assembly or even things like CNC machining, injection molding, 3D printing, and you can use PCBWay for all of those services. Plus, if you need PCBs, you can use the link down in the description and you can get 10 PCBs for free, only paying for shipping. So thank you PCBWay, and let's get back to our menu. Now, the title of this video says 3D menu, but obviously this is not a quote-unquote a real 3D menu, but it has this 3D movement and this perspective scaling, so it kind of looks like a 3D menu. Or we can just say a 3D menu with 2D icons, and the icons are actually something that we need. The good news is that I already have those icons because I already have a video with a menu project, that's this one, and I describe the process of drawing those icons in that video using a tool called Photopea, so if you want to know more about this process, you should definitely watch the video. For now, I will assume that you know how those icons were made and that I have a few of those icons that I can use for my 3D menu. Now, the first step of creating this 3D menu is to somehow moving those icons in the 3D space. And this menu effect is oftentimes called carousel menu effect because it feels like those menu icons are moving around the carousel. So let's try to do that. And to show my steps and thought process, I will be using software called Adobe After Effects. Now, in order to create a menu, you don't need to have After Effects installed or even know how to use it, but hopefully it will help you with understanding the concept because I can easily animate elements in there without the need to write the Arduino code at this point. So let's add those icons into our project, into our composition, and see if we can animate those. And since After Effects is specifically done for animations, we can just open the transformation properties and add a new keyframe for position, then move it to a different position, like so, and keep moving around until we will have some kind of animation. But this movement looks kind of strange, so maybe instead of doing it this way, I will just delete those keyframes and draw a new ellipse. For example, like this, and then open the ellipse path, so copy this into the clipboard. I don't need the mask anymore, and I'll just paste it into the position keyframe, and then I can move it to the right position, and now the icon should be animating around this ellipse. Our display only has black and white colors, but here we have some grayscale ones, so I'll just change the quality to be the lowest one, which is this one, so we don't have grayscale pixels anymore. And maybe I will make this animation longer, going all the way to frame number 150. And I want to keep the animation playing over and over again, and for that I can insert a simple expression saying loop out, and that will make sure that it will just keep animating over and over again. So I'll just copy and paste the position to all the other icons, and of course change the quality to be the lowest one. And now I want to apply some offset, so I'll select all the keyframes and move them 30 frames to the left side, 60 frames for this one, 90 frames for this one, and for the last one it will be 120 frames. Like so, and now we have all the icons nicely spread on the canvas, so if I play animation like this, you can see they are animating. And it looks quite nice, and we've only spent a few minutes creating this animation, but it doesn't feel like those icons are moving on the 3D carousel. They are just moving following the ellipse path. And if you open the real image of the carousel of the roundabout and imagine that you are sitting here spinning around, you are indeed following the ellipse path, but because of the perspective, the movement will seem faster when you are on the front compared to when you are on the back, where the movement will seem slower. And if you sample those positions, they will be most likely spaced apart like this on the front, and there will be smaller spacing on the back like so. Whereas if I compare it to our movement, you can see that those individual keyframes have the very same spacing. All that means that perhaps instead of using the ellipse for the position, it might be better to use the real 3D position. Thankfully, that's quite a simple task in After Effects. I can create a new layer, and let's create a new solid layer that's just a plain fill layer, and let's name it Layer 3D Position. I guess 32 by 32 pixel is fine, and for the color I will go with, for example, a blue one. Click the OK button, and I can turn this layer into the 3D layer by clicking this 3D checkbox like so, and now it's in the 3D space. And if I open the transformation, I can rotate it around the y-axis like so, but I want to have some slight offset, so I'll increase the anchor point for the Z position to maybe, I don't know, 36 or so. And now when I rotate it around the y-axis, you can see that we have some kind of movement that we are looking for. So the only missing piece is to tilt it a little bit. And for that, I will increase the X rotation to maybe, I don't know, plus 27 or so. And then I will go to the first frame and create a new keyframe for the Y rotation being 0 degrees. And on our frame 150, I will rotate it full circle being 360. And maybe I'll hide those icons so I can see only the 3D layer, and you can see that it's being rotated in the 3D space. And I will use the same trick with the loop out function, so it continues with the animation over and over again, so it rotates around like that. Now again, this is the 3D layer, and our icons are just 2D layers. So if you want to get the position, for example the center of the layer, and use that position for our 2D icons, we need to convert that 3D position into 2D position. For that, I will create one more layer and again use a solid layer, and this time call it 3D to 2D, and maybe use a different color, for example, I don't know, the magenta one. Hit the OK button, and now for our positions, I'll open the position. We want to create the expression, so I'll click on the position keyframe, and I will use this pick whip icon to get the layer 3D position name, and type in the dot, and the function that I'm looking for is called toComposition. That will convert the 3D position to the 2D position. We just need to specify the 3D point. And since our blue layer is sized 32 by 32 and we want to get the center of the layer, the X will be 16 as well as the Y, and the Z point will be 0. So if I write it like this, now the pink layer, let's actually make it a little bit transparent, will follow the center of the blue layer. So if I play the animation and rotate this around, you can see that the 2D pink layer is sticking to the 3D blue layer. Now before we use this position for our individual 2D icons, I will do one more thing. If I zoom in, you can see that we have some transparent pixels because the position is being set to decimal values, and I want to only have integer values, so I'll create a new variable called new position, and then use the math round function to round the X value of the new position, so that will be the index of 0, and do the same thing for the Y position, that's the index of 1, and then place it into the 2D array, so X and Y position like this, and suddenly it jumps to the integer position, so now we get only integer positions for this 2D animation position. I also want to move everything more to the top because there will be this label on the bottom of the screen, so for our 3D layer I will increase the Y position, maybe to 20 or so we have the space for our label on the bottom. Which means that now we can use this 3D to 2D position for our individual icons. So I'll just move those icons on top like so, open the position and just get rid of all the keyframes as well as all the expressions, because instead of using the loop out expression, I want to get the position of the 3D to 2D layer. So again, I will use the pick whip and pick the position from this layer, and this will give me this expression, and I can of course use it. And if I show this icon, the icon will be following this layer as expected, but if I use this very same expression for all the icons, they will be displayed on the very same position. So what I need to do is to type in value at time to sample the position at a different time, and if I just put in some value, for example 1, this will always show me the position on 1 second. I want to have this offset, so I'll type in time plus 1, and now the offset is 1 second. So as I scrub through the timeline, you can see that the icon is offset in time by 1 second, but I don't like to put in values in seconds because I'm working in frames. So I will type in frames to time and convert frames to time. My animation length is 150 frames and I have 5 items, and I want to multiply it by number going from 1 to 5, and I can hard code this number like so, or I can also use this number, which is the layer index, and I can do that simply by typing word index. Then I can just copy this position and paste it for all the other icons and make them of course visible. and at the same time make those two layers invisible. And if I play this animation, you can see that we have a nice looking movement. And of course the icons on the front are moving faster than the icons on the back. So now we have a true 3D movement converted to 2D positions. And while it looks nice, there is still something missing. With the perspective projection that we are using, something like this, the icons on the front should be bigger and the icons on the back should be smaller. And of course everything in between should be somehow in between those two sizes. And scaling those icons is very simple. I just need to open the scale property and scale it all the way up to 200% or so. However, as you can see, it doesn't look very nice. It's very pixelated and horrible looking and kind of expected because we are scaling very small image to be double the size. So every pixel is now 2 pixels, actually 4 pixels, 2 by 2 pixels. So perhaps instead of scaling 16 by 16 pixel icon all the way up to 32 by 32 pixels, let's try to do the opposite. So what I've done is I've recreated the 32 by 32 version of this icon, which looks like this and looks nice. This is the 100% view. And now I will scale it down, so from 32 by 32 pixels, scale it to 50% to be 16 by 16 pixels. And it kind of looks nice with all those grayscale pixels, but we cannot show grayscale pixels on our OLED display, which means that I need to add a new adjustment layer and apply the threshold effect to only have black and white colors. And here you can see as I scale it down, the 16 by 16 pixel version looks kind of different from our 16 by 16 pixel version. Actually, let me just put it in there so you can see the difference. So this is my hand-drawn 16 by 16 pixel version, and this is the 32 by 32 pixel version being scaled down. You can see those double pixels around the edges. It doesn't look very nice. And this is how it should look like. So what I will do is I will use this 32 by 32 pixel icon to scale it down, but I will also use this 16 by 16 pixel version and scale it up, so scale it up to 200%. And then as I'm scaling those, I will blend between those two. So this 16 by 16 pixel version, I will start with 0% opacity, so I only see the 32 by 32 pixel version, and as I scale it down, on the very end of the animation, I will fade in the 16 by 16 pixel version. So now it looks fine for both the small icon and the big icon. And everything in between is kind of strange looking. You can see that some of those keyframes are, just ugly. But the idea is if I play it fast enough from the small version to the big version or from the big version to the small version, you will not have time to closely look at those in between keyframes, and all you will see is just this smooth looking animation. Which means that for our menu, what I will do is I will only show the selected icon to be in the 32 by 32 pixel version in the big version, and all the other icons will be in this 16 by 16 smaller version, so it will not be a true perspective scaling, but there will be at least some scaling happening. And since I have this icon that's already scaling, I think that I can just use it. I will just rename it to be icon scaling gauge and jump back into our menu. And here I will select this gauge, which is this layer, and of course change the scaling back to 100%. And I think that what I can do is to just keep this icon selected, then select our scaling gauge composition and drag it over with the Alt key being pressed, and then it will just replace this with this composition. If I scrub through the timeline, you will see that it's big in the beginning and then it just scales back because it's just taking this animation from this main composition. I don't want to do that, I want to resize it in a different time, and for that reason I will enable time remapping, get rid of this keyframe and only show it at 50%, and then when the icon is in the middle being selected around this frame, so frame number 90, I will set the frame to be frame number 0, so being scaled up. Then move a few frames forward, and I believe that the frame where the icon was on the smaller size was frame number 30, so I'll set it to frame number 30 for one side and also for the other side, like so. And as a result, when I get to this icon, it will scale up and then it will scale down. So when this icon is selected, it will be in the bigger state, and when it's not selected, it will be in the smaller state. So now it's just a question of doing the same thing for every single icon. I have this icon scaling gauge composition, I'll just duplicate it and for example do the one for turbo gauge, so rename it to turbo gauge, open this icon scaling turbo and replace the images with the turbo icon images. So this is the redrawn 32 by 32 version and this will be the 16 by 16 version. And when I move through the timeline, I have another icon being animated. In the end, I have 5 icons that are resizing: the gauge icon, the turbo gauge icon, the GPS icon, then the parking sensor icon, and the 3D cube icon. So all I need to do is to replace those icons in the main menu. So this is the cube icon being replaced with the scaling cube icon. Again, right click and select time, enable time remapping. And for now, just set it to the frame with the smaller icon. Same with the GPS, replace the GPS, enable time remapping. Set it to the frame with the smaller icon, also with the parking sensor. And finally with the turbo gauge. You can see that some of those icons are cut off. If I show the transparency, you will see that the size of those images is 32 by 32 and they do not have a transparent background. I think that a quick fix will be just set the blending mode to screen to just ignore the black color and that should fix it. But we still have only one icon being scaled. And while we can use a similar approach of defining the scale animation on this layer and then referencing it using the expressions, I think much faster way will be just copying and pasting those keyframes, of course with some offset. In the end, the animation might look something like this. Now before running it on the Arduino, I want to make two more changes. First of all, I want to add some kind of easing, so it will just slow down when it's approaching the item, and that it will speed up again. And I believe that I can do this with the rotation animation on this layer 3D position. I will just add more keyframes, so for frame number 30 I will add a keyframe, and then for the frame 60, 90 and 120. So for all these icons that are being selected, and then I will select all the keyframes and add the easing, so easy ease. And now when I play this animation, it will just slow down when it's approaching the item, and then it will jump to the next item. And I can make it even more dramatic by setting the keyframe velocity to, for example, 60% instead of 33. And now the jump should be much more obvious. And I like this kind of animation. So the very last step is to add some kind of label, simply by selecting the text tool and then typing something, for example, turbo. I will use the font pixel operator for now and set it the white color, and then of course position it to be in the middle on the bottom, and make sure that the position is set to integer values so I don't see any of those semi-transparent pixels. And just for testing, I will keep the label static for now. So this is what I want to try on the Arduino, and I think that the easiest way how to try it is to just export this as a flipbook animation, so each individual frame as the image, and then try to run it on the Arduino and the OLED display. But before exporting this animation, let's talk about the memory usage. So one frame of 128 x 64 pixels, when we only need 1 bit per pixel, takes 1024 bytes, and we have 150 frames, so we would need 153 kilobytes. However, on the Arduino UNO that I'm using, we only have 32 kilobytes of memory, and even when we say that we only want to play 30 of those frames, it might still be a problem because there are other things in the memory. So let's see if we can somehow make this image smaller. And as I play this animation, you can see that in this area and in this area there is actually nothing being animated, and the bottom part for now is kind of static, so the exported image could be much smaller. And we can actually measure the size of all those pixels by just adding a new adjustment layer and then applying the time echo effect, and that will pretty much show the previous frames. So if I select 10 of those previous frames, I will see what was there previously for 10 frames, like so. And I can up this number to 150, so for all our keyframes, I will pretty much keep adding more and more pixels. So by the end of this animation, I will see which pixels are being drawn, and this is the area needed for our exported image, which I've measured to be 96 by 54 pixels. And again, I will only export 30 frames. So I'll place it like this, and of course align it like so, and then export those 30 frames by going to Composition, Add to Render Queue, set the output format to PNG file, and export those by clicking the Render button. This is how those images looks like, so let's try to display those on the Arduino UNO and the OLED display. And I will start in Vocwi, which is a free online Arduino emulator, because I have this video which is called Image to OLED in 60 seconds. And if I scroll down, there should be a link to the Vocwi project that is just showing the image on the OLED display connected to the Arduino UNO. And if I look at the code, most of the code is taken with this image data, so if I collapse this, you can see that all that's left in here is to including the U8G2 library for drawing on the display and the wire library for the I2C communication. Then I'm initializing our display, and in the setup function I need to call the begin function, and then inside the loop I'm clearing the buffer, then drawing the image to the buffer and then sending the buffer to the display. And there is some delay, but that's really not needed because we are not doing anything else. So let's see if we can use the very same sketch to draw our exported images. And to draw them, we need to first convert them to the C-style array, something like this. And for that, I will be using the Image2CPP website and select all our images, like so. And then scroll down for the preview. I just need to click this swap checkbox, and then click the generate code and copy the output. Jump to our sketch and get rid of this image because we don't need it. And instead paste our exported images. And you can see there is quite a lot of data in here. For every single frame we have this data, and on the very end of the list there is an array that's referencing all those images. But maybe let's just try to draw one of those images. I will just copy the name into the clipboard and paste the name into our drawXBMP function. Now the size is not 128 by 64 pixels, but instead it's 96 by 54 pixels. So I'll just update those values. So it's 96 times 54 pixels. And just because we want to have this image aligned on the x-axis, we should set the x position to be 16 instead of 0, like so. And then we can restart the simulation. And indeed, we see the very same image on the OLED display. So instead of just drawing one image, let's just switch between those individual images to play the animation. And for that, I will create a new variable called frame that I will set to 0, and one more variable called frame increment that I will set to 1. Inside our loop function, I will set the frame to be frame plus the frame increment. And if the frame is bigger than 30, so it's the end of the animation, and the increment is also bigger than 0, so it's animating forward, we will set the frame increment to be -1 to reverse the animation playback. And if we are on the other side of the animation, meaning that the frame is smaller than 0 and the frame increment is also smaller than 0, then we will set the frame increment to 1. Now, instead of referencing the image like this, we will use this array instead. So just copy the array name into our drawXBMP function. And as for the index, we will use our frame variable. So let's restart the simulation one more time. And you can see the animation is playing, but at some point we see some kind of garbage. And I guess that's because we don't want to go all the way to 30. We only want to go all the way to 29. I mean, we have 30 frames, but we count from 0. So one more restart, and we see a nice looking animation. Before running this on the real Arduino, let's add some label to the bottom of the screen. And if I open the U8G2 documentation, there is this function called drawString. And the example here shows how to set the font and draw the string. I will copy both of those lines into our sketch before sending the buffer to the display. Maybe instead of hello world, I will say 3D menu. But the default font, if I restart the simulation, is way too big. So I will again jump to the documentation, and up on top there should be a link for the U8G2 fonts. I will select the small fonts, and there is quite a lot of fonts to choose from. I will, for example, use this U8G Helvetica font, so I'll just copy the name into our sketch. Now the font should be much smaller, so it's just a question of positioning in the middle of the screen and on the bottom. And I'm just guessing those values because those are not that important for now. And it looks like that the values of the x being 44 and the y being 64 work just fine. So let's try to run the very same sketch on the real Arduino. And as a first step, I will connect the OLED display to the Arduino UNO in the very same way that it was connected inside the walkway sketch, meaning the ground will go to ground, the VCC will go to 5 volts, and then the SDA, the serial data, will go to either pin the A4 or the dedicated SDA pin. Those are actually the same pins. And then the SCL, the serial clock, will either go to pin A5 or the SCL pin on the Arduino UNO. And once we have it connected like this, we can connect the USB cable to the Arduino UNO and jump to the Arduino IDE. Actually, I will first jump to the walkway simulation and copy the code into the clipboard, and then open the Arduino IDE and paste the code in here. Now we are using the U8G2 library to draw stuff on the display. If you have never used the library, you have to go to Libraries, and then type in U8G2 and install this library. You can see that I already have this installed, so close it. Then select the Arduino UNO on the drop-down menu and click the upload button. And after a few seconds, we should see the very same 30 frame animation running on the Arduino UNO. And it's not super fast, but it's not slow either. And when I was testing it for the first time, this sketch actually gave me a confidence that something like this could be done on the Arduino UNO. You see right now we are drawing an image that takes almost the half of the screen, but for the final version we will be drawing 5 icons, and out of those 5, the 4 icons will be only sized 16 by 16 pixels, and the one icon, the one in the middle, the one being selected, will be 32 by 32 pixels. And of course, don't forget about the label on the bottom, but if you do the math, you will find out that there are not so many pixels to change and draw, which means that it could only get faster than this. Also, I don't worry about the memory usage that much because, again, I will be only storing those individual icons in the size of 32 by 32 pixels, and most likely that will take less memory than we are using right now. So let's do the next step, and that will be exporting each individual icon with some number of frames with this scaling animation. And right now we are using 30 frames for each scaling animation, but I don't think that we need that many frames. So what I will do is I will update those individual icons to only have 10 frames instead, so I'll just move those keyframes and make sure that also the animation length is only 10 frames. That will be useful for exporting, and do that for all the icons. I also need to update the time remapping keyframes to only go up to the value of 9. When I play the animation, there is really very small difference between having 30 frames or 10 frames for scaling. At least I don't see any big difference, so what I will do now is to export each individual gauge, having 10 frames going from 1 to 9, and then having one more frame, the frame number 10, and I will tell you why I have this extra frame in a minute. And one by one I will select those icons and select composition, add to render queue, set the PNG file format, the image name, and click the render button to save those frames as individual PNG images. And in the end, after exporting all those images, I should have the animation going from the 32 by 32 pixel version going down to the 16 by 16 pixel version, which is this one, so 10 frames for each individual icon. But I have one more image for each of those, and that's this one. It's actually the very same as the last one, so those two images are the same. But what I want to have is to have this image in the 16 by 16 pixel size. And of course the idea is that when I'm drawing this transition on the big icon, I will be drawing those 32 by 32 pixel images, but once I reach the end point of having the small icon, I will switch to the 16 by 16 pixel image, mainly for performance reasons, because I will be drawing smaller images. You can use any tool to crop those 5 images into the 16 by 16 pixel size. For example, Photopea, which is a free online graphic editor similar to Photoshop. I will open the image, then jump to image canvas size and change it to 16 by 16 pixels, like so, and of course save it. And if you allow it, it should directly save the PNG image on your folder. So let's do that for the other icons as well. And once we have a set of images like this, we can again use our image to CPP tool to convert all of those images into the C-style arrays. Let's check how they look like, and don't forget to click this swap checkbox, and then click the generate code and copy the output. Jump into our walkway sketch and delete pretty much everything that we have for the data, so for all those frame images, because we don't need them anymore, and I will paste our new set of images, like so. Now we want to draw those individual icons on different positions, but we don't have those positions in the code yet. Those are still in After Effects, and that's this layer, so this layer has all the positions that we are looking for, and we want to somehow extract those positions from After Effects and use them in our code. And to do that, I will create a copy of this layer, open the properties for position, and then select animation, keyframe assistant, convert expression to keyframes, and that will create me a keyframe for every single frame. You can see that as I zoom in, those individual dots are those positions that we are looking for. I only need those to go to frame 150, so delete the rest of it. And then when I click the position and copy it, and paste it into the notepad, you can see that I have all those positions data, being the frame number, the X position, the Y position, and the Z position, which is set to 0. That's kind of expected. Now, of course, we want to use those values inside the array in Arduino. And for that, we need to add some commas and brackets. And I think that the easiest way how to do that for many elements is to use the irregular expression. And I like to use this website because I can easily see what's going on and type in my regular expression in here and immediately see what I'm searching for. So first I will search for the tab character, which is this one, then for any number of digits, again the tab character and any number of digits, and tab character and any number of digits, one more tab character, any number of digits, and then the final tab character. So this will search for the entire line, and I want to capture some of those groups. So the first digit I will capture, that will be the frame number, the second digit will be the X position, and the third digit will be the Y position. Then I want to of course replace those, so click the replace button, and I want to start with the curly bracket, maybe add some comment, inline comment, and inside this inline comment I will insert frame, and the frame number is captured in the group number 1. which doesn't seem to be working. Maybe instead of backslash, I should use the dollar symbol. Yep, that one is working. And then the X value is captured in the second group, so the dollar symbol 2 for the second group. That's the X position, and the third group will be the Y position. And I need one more comma after that. So we can use this array inside our code. So I'll just copy this one and paste it in our code. And I need to do a few more changes. This is to the array. I need to have one set of brackets outside everything. And the type of the array is the bytes. And let's call this array menu positions. And I should have 151 keyframes going from frame 0 all the way to frame 150, which seems to be the case. And for every single frame, I have two values for the X and the Y position. So we have the icons and we have the positions. Let's try to draw those icons on those positions. I will keep the frame variable, but I will just increase it by 1. And if it goes over 150, I will set it back to 0. And then as for drawing those icons, I will create a for loop to go over every single icon. So going from 0 all the way to 5, actually 4 for 5 icons. And I will calculate the index of which position to draw based on this frame value. So let's just call it item position index, and that will be based on the frame value. And we know that the spacing in between those icons is 30 frames. So it will be plus I times 30, but that should go outside of the range of 0 to 150. And for that reason, I will use the modulo function of 150. So it should never go over 150. And then I will get the X position, which will be based on this array, on this table that we just created, which is called menu positions. And the first index will be the item position index. The second index will be 0 for X position. And in the very similar way, I will calculate the Y position from the very same menu positions array, with the first index being item position index and the second index being 1 for the Y position. And for now, let's just draw those smaller images. And if I look into the main array, those smaller images are with the suffix of 10. So I believe that I can use the index of I times 11. And of course, the X position will be X position, Y position is Y position, and the size of the image is 16 by 16 pixels. And I hope that's all that's needed to draw those small icons. So let's restart the simulation. And I guess I was wrong. There were actually multiple problems with this sketch, and the missing semicolon is the smallest one. You've probably already noticed, when I was writing the regular expression, I've wrongly used the very same group for both the X and Y, so you can see that those are the same numbers. I should have used the group number 3 for the Y position to get the correct Y position. That's the first thing. The next thing is that the X and Y positions are actually the center positions of those images, so we should subtract the half of the size, so -8 for both the X position and the Y position. And even the index was wrong because the Y goes from 0, and 0 times 11 is of course 0. And if I show the array, I don't want to use this one, so I guess I need to add 10 to this, so it will be I times 11 plus 10, and hopefully now it should be better. And indeed, we see some icons being animated. Somehow they are blinking and we are missing the label on the bottom of the screen. And I know exactly what's wrong, but unfortunately it's quite hard to tell from walkthrough simulation, and that's because walkthrough doesn't tell you about the memory usage. The problem that we are facing is that we are getting out of memory, and we can easily tell it by copying the code, then going into the Arduino IDE and pasting the code in here, and clicking the verify button. That will not upload the sketch to the Arduino UNO, but it will compile it and tell us the memory usage. And you can see that we are using 96% of the dynamic memory, of the RAM memory, and that's not counting for the local variables, and that's most likely the reason why we see those blinking elements and missing strings. And there are two big reasons for using pretty much all the RAM memory. The first is our array with all the positions. We have 151 positions and we need X and Y values, which means that we are using 300 bytes for just this array. The second thing is the buffer for the U8G2 library. We are holding the entire buffer of the 128 times 64 pixels in the memory using 1 bit per pixel. So we are using 1024 bytes for this full screen buffer for the U8G2 library, and that's pretty much half of the memory that we have. Thankfully, the U8G2 library has multiple modes. It has the full buffer, which we are using right now, and you can see that the documentation says that in a full screen buffer it's fast, but it requires a lot of RAM memory, and that's what we are using. We are clearing the buffer, drawing stuff on the display, and then sending the buffer to the display. If we use the page buffer, it will be slightly slower, but we will use much less RAM memory, because now the display is split between 8 or 4 different pages, and we are updating only one page at a time. Now to switch from the full screen frame buffer into the page mode, we need to do a few things. First thing is the constructor that we are using all the way to the top, which is this one. And here you can see that it has to include 1 or 2. So I will open the constructor page and search for our constructor, which is this one, using the F4 full screen buffer. We need to either use this one with the number 2, that will be the page size of 128 by 16 pixels, or this one with 1 inside, and that will be the page size of 128 by 8 pixels. I will go with the second one, so just copy this into our code and of course comment out the previous one. And this is the page mode, and then go back to this documentation, and you can see that instead of using our functions for clearing the buffer, which is this one, and sending the buffer to the display, we need to use this do while loop. So I'll just copy those 2 lines before drawing everything, and this while section after drawing everything, and this will go over every single page and do the drawing. So let's restart the simulation, and now we see the same menu but without the blinking and with the label properly rendered. So let's actually try that on the real Arduino again. I will copy the code and paste it into the Arduino IDE. Make sure that the Arduino UNO is still being selected and click the upload button. And once this is uploaded, you can see that we are now only using 60% of the dynamic memory. And of course we see the menu animation on the real OLED display, which kind of looks cool even without the scaling. But since we have those scaled images already in the code, let's add those to the animation and scale the selected icon. I will add 2 more variables. The first will be the icon size, because the icon size could be either 16 by 16 pixels or 32 by 32 pixels. And then I will add 1 more variable, and that will be the icon scale frame. And that will be the frame going from 0 all the way to 10, 0 being the biggest icon and 9 being the smallest one, and 10 being the same as 9 but being the 16 by 16 pixels. And we will set both of those values based on the item position index, and the item position index is of course the rotation of those icons, starting from here where the value is 0 but at the same time 150. And I will say if it's between 0 and, for example, 20, I want to show the scaled icon. And since, of course, I only have 10 frames, I will show frame 1 for 0 and 1, frame 2 for 2 and 3, and so on and so on. And I will do the same thing on the other side of the circle. So going between 130 to 150, I will show the scaled icon in this area as well. So let's turn this drawing into the actual code, and I will say that if the item position index is bigger or equal 0 and at the same time smaller or equal 18, in that case the icon is somewhere in this area, which means that the icon size will be 32 by 32 pixels, and the icon scale frame will be based on this item position index, and I will simply divide it by 2. In a very similar way, if the icon position index is bigger than 132 and smaller or equal 150, I will again set the icon size to be 32, but the icon scale should go in the opposite direction, which means that it will be 150 minus the item position index and then divided by 2. Finally, the last case is if the icon is anywhere else, and in that case the icon size will be only 16 by 16 pixels and the icon scale frame will be 10, which is the index of the unscaled version of the icon. So let's use those 2 values in the drawing function. The x position will be x position minus icon size divided by 2. The y position will be the I position minus icon size divided by 2. And then of course the icon size is icon size for both the width and the height. And the item that we want to draw is based on the index I times 11 plus our icon scale frame. So let's restart the simulation and see what happens, and actually get rid of those drawings so we can see it nicely. And indeed, now the selected icon is getting bigger. And I really like how it looks like, so let's try that on the real Arduino. Let's copy the code into the clipboard, jump into the Arduino IDE and paste the code in here and click the upload button. And in a few seconds, we should see this menu with the selected items being scaled up on the real Arduino on the real display. And again, I think this looks great. I'm really happy about how this project turned out, but obviously at the same time, there is quite a lot of stuff that we can improve and add, like changing the label based on the selected item, calculating the 2D position instead of using the lookup table, so you can have more icons or less icons or whatever number of icons that you want, to using more powerful microcontroller, for example something like ESP32, so we can maybe even do the resizing of those icons on the MCU instead of doing this inside After Effects. I would like to try all of that, but most likely in the next video. Today it was more about the proof of concept and making sure that something like this is indeed possible. As usual, all the files are on GitHub, the link is in the description. If you have any questions or comments, please put those down in the comment section. Thank you very much for watching, and I hope to see you soon. Thanks and bye.